Corals are ancient animals related to jellyfish and anemones. An individual coral is known as a polyp, a very small, simple organism consisting mostly of a stomach topped by a tentacle-bearing mouth. The polyps extend their tentacles at night to sting and ingest tiny organisms called plankton and other small creatures. Thousands of identical polyps live together and form a coral colony. Each polyp excretes a calcium carbonate exoskeleton beneath it, and over long periods of time, the skeletons of many coral colonies add up to build the structure of the coral reef. Reefs only occur in shallow areas that are reachable by sunlight because of the relationship between coral and algae. Various types of microscopic algae, known as Symbiondinium, live inside of the coral, providing them with food and helping them grow faster. In many ways, reef-building corals are animals that act like plants. They stay in one place and get their energy from the sun. Coral reefs are found all around the world in tropical and subtropical oceans. They are usually found in shallow areas at a depth of less than 150 feet. However, some coral reefs extend even deeper, up to 450 feet deep. Despite how important coral reefs are to life in the ocean, all of them in the world add up to less than 1% of the sea floor. One of the most serious problems that corals face today is global warming. When temperatures are too high, the relationship between corals and their symbiotic microalgae breaks down. The algae are what give corals some of their bright colors, so when this happens, corals appear white or bleached. Just 1 degree above the typical summer max is enough to bleach many corals. If the temperature is too high for too long, corals and their microalgae are unable to recover. Over the past 30 years, bleaching has become more frequent, more intense, and more widespread. This has led to massive die-offs of corals throughout the world. Another problem corals face is the acidification of the oceans. Seawater absorbs some of the excess CO2 from the atmosphere, causing the oceans to become more acidic. As a result, the ocean's acidity has increased by 25% over the past 200 years. These acidic conditions dissolve coral skeletons, which make up the structure of the reef, and make it more difficult for corals to grow. If left unchecked, scientists estimate that the oceans could become 150% more acidic by the end of this century, making it very hard for corals to grow at all. Thank you for watching this project by William Hajati and Sebastian Castillo.